All right, so we're here to prepare for our test over proportions. All right, and this will be a very challenging test. So hopefully you guys put in the work. You're focused now. You're asking questions if you don't understand. All right, and I'm going to show you the links again that we'll be using. All right, so number 2. Now, number 2 is asking you to find the standard error for a confidence interval for a difference in proportions. Now, the formula for this, which will be given to you, so we'll take the hat off, is going to be P hat from group 1 times Q hat from group 1 over the sample size of group 1 plus the P hat from group 2 times the Q hat from Q2 over the sample size of group 2. Okay, that is the formula for the standard error for this difference in two proportions. Okay? So when I look at my answer choices, I'm looking for things that look like that. Okay? So when I'm looking at this chart, I see 183 is the first group, right? So I have 183. And it says 59% are reporting they get 7 hours of sleep or more at night. So then the Q hat is 1 minus that. So that feels good. And then I look at 88 adults in the second group. It says 52% are reporting they sleep 7 or more. So then 1 minus that. So, I mean, I don't have to go any further than A. That's well done. Okay. Number 3. Number 3 is asking you to pick the answer choice for a 99% confidence interval for a proportion. So immediately when I was reading these answer choices, I was like, what is happening there? Okay? Because this, if we think about a proportion, right? If we think about a proportion, if it's going to have 2 proportions, like this is showing 2, then this should be a difference as well. Okay? And they're just trying to confuse you with these. So I think what happened was they had all these answer choices, A through D, and like, oh man, we've got to come up with one more. So they did that, and that's just not okay. All right, so the question is, how do you differentiate between these answer choices? Now, I think I would normally tell you to go to the confidence level first. But unfortunately, 99% is not one that I have memorized, so I'm not going to go there first. I will get there, but not first. The first thing I'm going to do is get the P hat. Do you see how the P hats are not all the same? All right, so we have options, so I need to figure out which one it is. What's my sample size? 500. How many are saying they own an electric car? 15. So what is that as a decimal? 0.03. Excellent. So that means I'm crossing out B and D. So now the question is, right, if you look at the answer choices, bless you, for A and C, they are exactly the same in terms of standard error. Do you guys see how their standard errors are identical? All right, the only thing different are the Z star, the confidence level of the Z star. So let's see if you can do this again. So I'm going to draw my curve. We're going to get there. All right? Yes, we're going to do Desmos. It's what level? 99%. So how much is in each tail? 0.05. Very good. It's 0.5% is in each tail, right? Because I got to split 1%. So 0.5% as a decimal is 0.005. So when I go to Desmos, I'm typing this into my inverse normal. Okay? So now, again, tomorrow when you have a Chromebook, or you can use your phone, I'm going to have a link on Classroom that, I guess I should say a line. I don't know how you guys see it. How I see it is like a link. But you'll have something you click, and then it will have all of the links that you potentially could need. All right, so you don't have to check your emails searching. Okay? So I'll have that ready for you tomorrow. And if I'm on my stuff, I'll have it for you in an hour. Okay, so I'm going to go to Desmos. Okay, this will be one of the links. Now, guys, just I'm going to let you know, I'm not going to really tell you much about the links. I'm just going to have the links for you. Okay, so when I look here, we've used this in the past, I need a Z star. So I'm going to use the inverse normal one here. So do you see where it says 0.1586? Right there, I'm going to type in I'm going to type in 0.005. What are you typing in, Leslie? 0.995 is what you could also type in. Don't type in 0.99 because that's not what I'm looking for here. I'm looking for the area, the Z star for that area to the left. So don't type in the confidence level. All right, that's why you have to do this work first. Okay? That's a really good question. Okay, so do you guys see how it's 2.576? So my answer is going to be C, 2.576. Yes, Catherine? How do I know when it's two proportions? They give you two groups. What, didn't we just have one? Yeah, see how this one had two groups? You had groups that exercised regularly and those that did not. So this one just says that they're trying to confuse you. Catherine's question is valid, guys. Listen, guys. Catherine is asking about how you know when it's two or one proportion. They're trying to mess you up by saying, here's all of the employees. This is the population. And from this population, they've had a sample. And from that sample is how we get our one proportion. So they're not talking about multiple groups. If they're talking about multiple, like different samples, then I'd have two proportions. So this is only one proportion.
Why did you do the 2 and 10?
Oh, no, the confidence intervals are always 2-10. Confidence intervals, I didn't know you were asking about that. I'm sorry. Okay. Number 4. Speaking of TwoTails. This problem, TwoTails. Okay, number 4. Wow, that's a lot of reading. Okay, so luckily you already did it yesterday and I did it.
20%.
Okay, now I'm hoping that there was a little less guessing involved. Maybe this did involve technology, so fair enough. Let's just look real quick. We have a null hypothesis that the proportion of overweight dogs in Florida, listen, is the same as the proportion of overweight dogs in Colorado. We're trying to see if that is not true, trying to prove that they are different, that the proportion of overweight dogs in these two states is different. Okay, so the moment I see that not equal to, that tells my brain that this is a two-tailed test, right? So I'll be shading up below, and I'll be shading above. Now, what does it say my z-score is?
0.05.
That's not my z-score. What's my z-score?
1.
I know it's weird because they didn't say it, but this test statistic, right? That test statistic is my z-score. So z is 1.85. Okay? But that also means that I care about, because it's TwoTails, I care about negative 1.85. And I'm looking for the area above the positive and below the negative. So let me show you what my brain does. So my brain knows that if I find this area, then I know that area is the same as this one. So I just have to double it. Ready? Back to Desmos. All right? But now I'm using the normal distribution function here. What's my minimum? What am I going to type in for my minimum? Actually, I'm going to type in positive 1.85. That's what it gave me in the problem. I'm talking about the one that's shaded to the right. And what's my maximum? Very good. All right, so infinity is a bunch of 9s. All right, so what's that area that's shaded to the right? 0.032. I'll write it down bigger for you. So this right here is 0.032. Now be careful. This is a two-tailed test. So what's the area down here? Also 0.032. So what is the p-value? Just got to double it. 0.064. So really this is what I'm using to make my answer. All right? And when I look at that p-value compared to alpha of 0.05, I immediately notice that my p-value is above my alpha. So before I even read the answer choices, I'm saying to myself that if I was writing an answer, I would say that there is not enough evidence to reject the null hypothesis. Right? So I'm going to fail to reject the null hypothesis. So I'm trying to read my answer choices for that answer. Okay? Notice that all 5 of them start with either there is not sufficient evidence or there is sufficient evidence. Well, I just said I'm starting with there is not enough evidence. So if it helps you, cross out C, D, and E. because I'm saying there's not enough evidence. All right, so we're trying to figure out which one is it.
B.
A.
Remember, it's all about the p-value, right? And my p-value is greater than 0.05. So it is A. We're going to stay till 2:04. Okay, that, Charlize, is a very hard question, right? Because not only do you need to understand your linkage, right, p-value and alpha, but you have to understand how to find it. Okay? So again, trying to get you guys prepared. This is going to be a hard test. There's going to be a lot going on. It's okay. We're going to curve it, right? You know I love curving. I'm recording right now. No, I'll curve it no matter what. Okay. Number 5. Muscle. Number 5. We have 1,018 city residents rating their level of support for a proposal being considered by the council. We have levels of support: very, somewhat, or not supportive. Now this again is a reading question. Based on the responses, which of the following is the 95% confidence interval for the proportion, so again, one proportion, who would respond very supportive or somewhat supportive? Now they're trying to mess you up here, guys. All right? My first question is, how many people are in the sample? 1,018. Now be careful here. What is a success? What is a success? Very or somewhat. So it's actually going to be 336 plus 387 is going to give me my p hat. Was it 723 over 1018? And what's that? I assume that's going to be the 0.71. So without going any further, and David, I know you love this, without going any further, I've at least increased my chances of guessing. Right? So if you don't want to do any more work, hey, at least you got now 1 out of 3 shot. Okay?
95.
Now, what I would say here is you have 2 options. For me, since I feel very confident, I know the formulas, I know how to use them, I'm very good at this. Obviously, I'm not trying to be, cocky here. I'm just telling you, I know what to do. So I would not use technology. All right? I would just write it out. So I'm going to do that first. But then I'm going to show you if you're someone who likes to use those links. Okay? So what I would do is I would find let me write the formula, p hat plus or minus z star times the standard error of p hat. Okay? We already know that p hat is 0.71, right? What's going to be my z star for a 95%? Very good. 1.96 times, let's see if you remember what's going to go here.
71
Times.
29 over 1,000.
See, I love it. And then I would use the yellow calculator to find out what this is. Let's see if anyone remembers what it's called. Remember what's this called? That's standard error times z star. What's that called? Very good. The margin of error. Okay. All right. Okay. Feeling good? All right. Okay. Jarvis, not feeling good. Right? Probably because Mr. Feek's going to take your jacket. But anyway, once you finish this,
You get
all my subscribers. I believe it's E. I believe it's E. Right? Good job. Now, if you're wondering how I got that, I would just use the yellow calculator to type that in. That is what is up. All right? Now, let me show you how to do it. Let me show you with a link, if you want to do a link. Right? This is a 1 proportion Z interval. So one of the links is the 1 proportion. There we go, 1 proportion. So how many favorable cases do I have? 7. What was it? 7. Oh, look, I already did it today. Yeah. Sample size was 1018. I remember that one. And then the confidence level was 95%. So I type in was it 95%?
Yeah.
So 0.95. And then I don't hit start. I don't need to convert. Calculate. All right, that'll take 6 years, so we'll come back when that's ready. Yes! Okay, now, do you guys see the interval? Sadly, the answer, right, the answer didn't just have the interval. So what I did when I did this with the technology was I took the 0.71, right, I already know it's 0.71, and I subtracted one of these. I chose the lower one. So if you subtract 0.71 minus this bottom one, you get 0.028. All right, so that's the margin there. Right, because remember, your interval always has p hat in the middle. Your interval always has p hat right in the middle of your upper and lower, always. Okay, that's a great problem. Big fan. All right, let's go number 6. All right. Okay, now I'll just be honest with you. Number 6, I dropped the ball. All right, because I did not really get into this when we first talked about confidence intervals. All right, I don't know why, I just dropped the ball. So that's my bad. So I want to make sure you understand what's going on here. Okay? It basically is asking you, what does 95% mean? Okay, and here's what it means. It means that if you were going to run 100 more samples and make 100 more confidence intervals, I'm going to say that again, it's so important. If I were to make 100 more samples of this many adults, okay? So 100 more samples. I do this again 100 more times and make 100 more of these. Will these numbers be the same? No, they'll be different. But 100 of these, then I expect 95% of them will capture the true proportion. That's what that means. That's what 95% means. Okay? So when I'm reading these answer choices, I'm thinking about that in my mind. Okay? So, really there's only 2 that sounded like what I just said. And that's B and C. Very good, Tom. Right? Approximately 95% of random samples of the same size from the population will result in the confidence interval that includes the proportion of all adults living in the United States who are satisfied with their health plans. Whew! All right, that sounds like what I said. Now look at C. You guys see that the only difference is that it says the proportion of all adults in the sample?
No.
So that's not it. What I'm saying is that it's of all of them in the population. So that's all of the United States. That's why it's B. I am guaranteeing you this is on the test. I'm guaranteeing you, Liam, so you want me to say it again? I'm guaranteeing you this is on the test. Right?
Wait, this is smart?
It is. The confidence level states that if you were to run repeated samples and make many more confidence intervals, 100 confidence intervals, then you expect 95 of those to capture the true proportion. Another way is, if I run a bunch of samples and a bunch more intervals, then I expect 95% of those intervals to capture the true proportion. Okay? That will, I guarantee you, it's on the test. Okay? All right. Oh, where did I put a link here? Nice. Number 7. Number 7. Okay? Guaranteed question like this on the test. Number 7. It says, basically, if I tell you a confidence level and a margin of error, can you tell me how many people I should sample? Right? And I did this problem. I've done it many times. So I'm going to use margin of error equals Z star times the standard error of P hat. I'm just going to be honest with you. I'm not going to give you this formula. Okay? I'm going to give you the formula here. Right? I'm going to give you this one. All right? So if you don't know that this is the margin of error, that's on you now. Okay? So you're going to get this one for a 1 proportion confidence interval. But I'm not going to go that step farther. Do you understand? Great. It's about to be algebra. Okay, so the margin of error they said is 6 percentage points, so that's 0.06, equals, what's the Z star for 90%?
4.645.
Excellent. Okay, times the square root, and then this is, I had this conversation with Guillermo, your group yesterday. Remember this? Right? When you look at this problem, it doesn't say anything about what P hat is. I have no idea what P hat is. All right, so if you don't know, we use 0.5 for P hat. So then, ipso facto, we use 0.5 for Q hat, and we solve for N. And then, you're right, Jarvis, this is an algebra problem. All right, so if you do all the algebra, I'm not going to do that, but if you do it, you move this over by division, you square both sides, then I take 0.5 squared divided by whatever I have, and you get, what was it, 188? You right?
Yes.
You get 188 when you round. All right? And you notice the answer's not here. but you always go to the next number that's after it. Make sure the next highest one, which would be 200.
So like, what if it was like 151?
Then 150, then 200. That's a good question, right? It's not about closer. It's not about distance. It's about, because here's why. Even if it was 151 and you chose 150, you'd have your percentage, your margin of error would be like 6.00001%. All right, and we want no more than 6. All right. All right, number 8. Number 8. Okay, the first thing I did when I read this problem, because I usually do this when I see an interval, is I just wrote down, okay, well, if that says 0.52 plus or minus this margin of error, then that's going to be 0.48 is the bottom one, and 0.56 is the top one. So I just made the interval. You don't have to, I just made the interval. Okay? So should the newspaper say that Smith will win because the majority of the voters are in favor of Smith? No. Why not? Okay. Okay, what about B? There's a 95% chance that Smith will win. This has nothing to do with his chances of winning, right? With 95%, 95% means that if we did it 100 more times, we'd expect 95% of those intervals to capture the proportion of voters that are going to vote for him. All right? The one thing I noticed about this problem is that in the interval, is there a chance that he will lose? Right? Why, Leslie? Well, right, nothing is 100%, right, except death and taxes. But what else? Just being honest with you.
Some people don't.
Okay. I'm not talking about evading taxes, right? That is a felony. If I'm talking about something else, go for it. Oh, you don't know, or is it IDK? No, that's when you die, you decay. Now, when you look here, do you guys see that we have potentially under 0.5? Right? In the interval, it doesn't go 0.5 to 0.8 or something like that, right? It doesn't go 0.5 to 0.58. So there's a chance that Smith could lose.
C.
So it's E.
E.
I mean, it's hard to say, like, it's exactly like this. No, Ureth, but like this idea of understanding that the interval, you have to be able to read the interval. That is going to be on.
Why is it number 10?
Well, let's do number 9. 9 is really hard. I think number 9, personally, if I had to pick the hardest question, it's number 9. Number 8 was E. Now, this is where I'm gonna try to make my money, okay? I'm gonna try my best here. Number 9, okay? I'm gonna try my best. So really open your brain to this one. It's definitely going to be on the test. Okay? Okay. We have a one-sided hypothesis test. Okay? One-sided. So one tail. And it says alpha was 0.05. Okay? So alpha is 0.05. Now it says after this, which is something you never really see, it says that we're going to assume that the null hypothesis is false. Right? So guys, if the null hypothesis is false, we want to do what with that? We want to reject it. If the null is false, we want to reject it because it's not right. We want to go in favor of the alternative. So it says now we're going to do it all again, but our alpha is now 0.01. So what has happened to the alpha? It's gone down. Now, from a long time ago, it's 3 weeks ago, maybe 2 weeks ago, I mentioned to you guys that alpha, right, is type 1 error. And beta is type 2. And there's always this struggle between them. So what just happened to type 1 error? It decreased. So if type 1 error goes down, then what happens to type 2 error? It goes up. So type 2 is going up. So right now what I would do is eliminate any answers that do not say type 2 increases. So not that one, not that one, and not that one. So again, David, by knowing one thing, you now have a 50% chance. Now I'm going to try my best to go to the next one, okay? Now, okay, the power of a test. Do you guys remember what the power of a test is?
No.
It is the ability of your test to reject false null hypotheses. All right? It's the ability of your test to reject null hypotheses that are wrong. Basically, how good is your test? All right? That's the power of a test. Okay? Now, the power of a test, okay, when I'm looking at this scenario, I'm going to make up a p-value. Okay? So, Jarvis, give me a p-value that would end up rejecting for 0.05. Now, it's something below this. Don't go that low. Go just a little low. Thank you. Perfect. That's awesome. So let's say our p-value is 0.04. Okay? With this initial test, our p-value is below alpha. So we would reject the null hypothesis. That is false. All right? We don't know it's false, right? But we would reject it. But if our alpha was 0.01, would we reject that null hypothesis?
No.
No! So if you lower alpha, you've actually made it harder to reject the null hypothesis. All right? And if you've made it harder to reject a null hypothesis that is false, then you have decreased the power of the test. It's E. Now that is hard. I'll just be honest with you. That's really challenging. I'm not sure 17-year-old me would have even gotten that. All right? That's really difficult. This will be on the test. Now, before I move on to number 10, you're going to be fine. Before I move on to number 10, let's have a quick discussion about type 1 and type 2 error. Because this question didn't really ask about what they mean. All right? It asked about the relationship between them, but not what they mean. So type 1 error. Remember, type 1 error is rejecting the null hypothesis, when in fact, you should not have rejected it. Should I write that down? Let's write that down. I'll write it here at the very bottom. Type 1 error is rejecting the null hypothesis when you should have, I don't want to say accept, but failed to reject it. Now, there are other ways to say it. Jarvis heard you would say accept, and before that you said, Jarvis, right, rejecting a null, that actually is true. That's another way to say it, right? I like this because it hopefully tells someone reading it that I still know the null is not true, right? It's just the best model of what's going on. Okay, so this is type 1 error. Rejecting the null when you shouldn't have. That will definitely be on the test. Okay? Type 2 error. Okay? Type 2 error is failing to reject the null when you should have rejected it. Any other free response answers? Potentially. Most likely no. But what's really nice about this, guys, is this test is going to be really hard tomorrow, but a lot of these concepts, now this is a good thing, because a lot of these concepts on the next couple of tests are all the same, right? All of the concepts are the same, we just changed the mechanics, all right? So I know it's going to feel like a lot, but you're basically prepping for the rest of the year by prepping for this test. Yes?
Is this test coming like this?
Yeah, absolutely. It's going to be awesome. Excited. Yes.
How much will our grade drop?
Well, it depends on how you do, right? It's 100 points. I would not worry about that tonight. I'd focus on studying. All right.
Hurry up.
Number 10. Okay, Catherine. Catherine says we gotta hurry up. Number 10. She has to use the restroom. Number 10. Now, Guillermo and Charlie, I think you were in this group, and Leslie maybe. I guess I gotta look at it. But those people that were in your group, right? I spent a good deal listening and then kind of talking about what we see in this problem. Again, this problem is riddled with misinformation, right? It's not a riddle, it's reading, right? But it puts things in, Daisy, on purpose at certain spots of the problem to mess you up, right? They threw this 12,000 here at the end to mess you up because this sample size is only 100. So A, B, and C are all wrong because they don't have the right sample size. 12,000 is the population. So again, that's on purpose, guys. They're doing that to mess you up. Now, this question you could have answered with one more step. Because now I know it's one of these two. What's the Z star for 95%?
1.96.
You did it. That's it. That's it.